Hi everyone, this is Mr. Richmond, and for this video I'm walking through how to do a couple different examples from your power calculations as well as electrical energy. So if you recall from class, we know that the formula is P power is equal to current times voltage. We are familiar with current and voltage from our Ohm's law calculations. So let's do a couple of these. And for the first one, I'm given current, so I have I. I'm given voltage V, 12 times 2. I need to solve for power, which is 24. Last step here is just to label my units, and power is in watts, so I'm just going to label a capital W for watts. Let's do one more that requires a little bit of algebra. And so I've got power, I've got voltage, I need to solve for current. And just like with our Ohm's law formula, we do the same thing. It's set up very similar to Ohm's law in that I want to get my unknown variable by itself, which I can do by dividing V or volts by both sides. So to get current, I'm left with P, power, divided by voltage or V. So that's going to be 1,000 divided by 120. And if I were to use my calculator app on my computer, 1,000 divided by 120, I believe is 8.3 repeating. Looks like that's good. So the last part that I need to do for this section is to make sure that I just label my units of measurement. 8.3 I'm solving for current, and that is amps, capital A. For part 2, you're going to be using the same kind of idea, just using some word problems here. You're going to be, again, using the power calculation, P equals I times V. I've got volts, I got current, so I'm just going to multiply these two together. That's going to be 240 watts. For the next section, we're really going to need to know, I'm going to let you try number 8 on your own, but for section 3 or part 3, we're going to need to know how to convert from watts to kilowatts and kilowatts to watt. And if you recall from earlier in the year, we know the prefix kilo from our metric ladder. So you may recall our King Henry mnemonic. King Henry died, kilo, hecta, deca. Here are all your prefixes. We're going to find watts right here under our base unit. How do I know that watts is a base unit? Well, it doesn't have a prefix like kilo, hecta, deca, deci, centi, etc. So I want to convert from watts, my base unit, to kilowatts. So I'm going from here, my base unit, 1, 2, 3 times over to the left to get to kilo. Or it's the equivalent of dividing by 1,000. So if I move the decimal point to the left, that's why I'm moving the decimal point to the left. That's the direction that's heading for my metric ladder. 10,908,000 watts is the equivalent of 10,908 kW, kilowatts. And finally, for part 3, I've got a new formula that we need to use, and that's going to be E is equal to P times T, where P is now in kilowatts. That's why it was important for us to be able to convert in part 2. Times time, which is going to be in hours, which is going to give us kilowatt hours, which is what our electrical company is charging us by on average in Connecticut. This is pretty close to a real figure. You're charged approximately 0.0839 cents for every 1 kilowatt hour that you're using. So let's use some math that might help you understand that a little bit better. We've got a 100 watt light bulb, which is pretty standard. And we are using that light bulb for 5 hours every day. And we want to know if we're using it for 1 month, we're going to assume that's a 30-day month, how much is that electrical company going to be charging us? So again, if we look at our formula, which is E is equal to P times T, I need to make sure that power is in kilowatts, so that's going to be my first step, 100 watts. Move the decimal point over to the left 3 times, so I've got 0.1 kW. I'm going to be using that light bulb for 5 hours a day. And it's up to you. You can calculate kilowatt hours first and then multiply by 30, because remember it's a 30-day month. Or you can multiply 30 times 5 right now, which I believe is 600 hours. Which is what I'm going to use right now, 600 hours. So 600 times 0.1 is going to be the equivalent of 60 kilowatt hours. However, I'm not quite done. I want to use this figure, 60 kilowatt hours, and if you recall, this is what the electrical company is going to be charging us by. So for every 1 kilowatt hour, we're getting charged about 8 cents per kilowatt hour. So the equivalent of 60 times 0.0839. That's from the electrical company. So my final answer is going to be about $5.03 if I were to round. It's going to cost us to run that 100-watt light bulb for 5 hours a day for a 30-day month. And the last example I'm going to go over for this video, if I'm using a coffee maker used for 3 minutes, what is the total electrical energy used? So again, I'm in watts here. I want to make sure that I'm converting to kilowatts, and that's the equivalent of 1.2 kW. The challenging thing about this is I want to make sure that I convert from minutes to hours, so 3 divided by 60. If I were to pull up my calculator, it's 0.05 hours, so times 0.05, and that's going to get me kilowatt hours. I don't know what that is off the top of my head. So 1.25 times 0.05. So it's going to cost me, or it's going to be the equivalent of 0.0625 kilowatt hours to run that for 3 minutes. If I were to use that for 30 days, I would multiply that by 30, so 0.0625 times 30. 0.0625 times 30. And my last step is to convert this kilowatt hours times the amount of money that the electrical company is charging me, and that's going to be 1.875 kilowatt hours times 0.0839 cents for every 1 kilowatt hour. My final answer is only going to cost me about 16 cents to run that coffee maker 3 minutes a day in a 30-day month. I hope you found this video helpful, and good luck with the rest of your assignment.